today, guys, is the problems that I am doing in class. Because this is where your exam is going to hit the hardest. Some of you absolutely have to pass. And it is very doable because the exam is not that long. It's 2 pages like a regular test, 1 page front and back, no calculator, 1 page front and back with calculator. It looks like a regular test. On handwritten problems, have an answer blank. Handwritten problems, have an answer blank. It's no different than a regular test. Plus, this is the reference sheet that you're going to be given. Okay? So all that is handed to you. Now, today, I'm not teaching you anything. I've tried to teach all this already. What I'm doing now is trying to jog your memory. So if you say, I have no idea what she's doing, then you go back on your own time, find the notes or the practice tests or whatever resources you have that have that kind of problem on it. Okay? So we are starting on review 2. I did review 2 last period. I just want to get everything on video. So we're going to finish review 2. There's 2 more problems. 31 and 32. This is on review 2. Problem 31 says find the slope of the asymptotes.
Mine only goes to 30.
Are you on review 2?
Yeah. No, it's review 1.
Okay, you need to be on review 2.
No, review 2 doesn't.
Review
No,
2.
review 2 only goes to 32.
Yeah, no.
Oh, well, then you have to write this problem down. I don't understand that, because how come I took my copy from the same pile you guys got. How come mine has that? I took it right out of here. Yeah, I don't know what you're talking about. This is what I handed out to you.
Yeah.
Yeah, and right over here, there's 31, 32,
Oh.
33. Wake up and smell the coffee, people. All right. So it says, 31 says, find the slope of the asymptote. So, on the test you just took, I gave you an equation like this, it's a hyperbola, and you had to find lots and lots. On the exam, you're gonna have to find something, all right? Just one thing. So in this case, it's the slope of the asymptotes. Okay, so how do we get the slope of the asymptotes? Where does that come from? Jacob?
Rise over run.
Rise over run, building the box, right? So if you think about, you don't have to graph this. You don't have to do any of this writing down, but you have to think about, okay, so I got my center is at 2, -3. And if I'm building the box, what am I gonna do? I'm gonna go over 4, or 3, and up and down 4. So what's my slope? If I'm going over 3 and up and down 4, then my slope is plus or minus 4/3, right? One of them's positive and one of them's negative. Okay? 32, find the center and radius. Well, you just did this yesterday also. These are the 2 most recent things. How do we find the center and the radius? And again, the exam might say, find the center, find the radius. Might say find both. It doesn't really matter. You have to do the same work, right? So what's the work we have to do? Complete the square. So x squared plus 8x plus blank, y squared minus 4y plus blank equals 10 plus blank plus blank. Now I know when we did this, I told you repeatedly, if there's a number here, like if the 10 were here, I move it to the other side, right? You can't just leave it there. You have to get it over. Now, what completes the square here? Half of 8 squared. Half of 4 squared. What perfect square is this right here? X plus 4. Now, if you say something else, like x plus 8, just think about that. Is 8 squared 16? No, it can't be 8, it has to be 4. Plus, what's this one? Y minus 2 squared equals 30. So, if the question says, find the center, you'll say the center is negative 4, 2. If it says find the radius, you'll say the radius is square root of 30. All right. Now, we'll hit the rest of the problems as we go through review 1. So now we're going to go through review 1. And like I said, I'm picking and choosing specific problems. And these are the ones you need to focus on. So, review 1. First one, review 1. We just were on review 2. Now we're going to review 1. Problem A. 1A. Very first one. If I am doing the problem today with you, it is on the exam. I can't read that number. I think it's 4. So this is on the exam. I honestly don't think the one on the exam is quite this complicated, but we might as well move through it. So how do you suggest we start? There are lots of things you could do to start. What do you think? So you could take everything in there to the negative second. So that includes 3 to the negative second, x to the, these get multiplied, so that's going to be 4, y to the negative 14th, 5 to the negative second, x to the negative second, and y to the 8th. You do not have to start that way. That's how she wanted to start, it's fine. Absolutely fine. All right, now what?
Change the negatives.
I would move everything with a negative gets moved. So, if it has a negative exponent, it gets moved. So 3 squared comes to the bottom, x to the 4th stays there, y to the 14th comes to the bottom, 5 squared goes to the top, x squared goes to the top, and y to the 8th stays down there. If it's negative, it moves. If it's positive, it doesn't. All right, now what?
Find like terms.
So if you notice right here, now they're next to each other. So you're not going to cancel them, you're going to total them. So I have x to the 6th and y to the 22nd. If they're on top of each other, they cancel out. What about these guys? 25 and 9, and that's the answer. That problem can be done in lots of different orders. Ultimately, everything that we just did has to be done, but it doesn't have to be in the order that we did it. All right, B. I apologize if we've already done this. We're gonna do it again. Okay. Now, take a look on your sheet. There is a little help for you there. Not a lot, but a little help there. Cosine over 1, you're not changing cosines and sines. Those are like the base units, we're not changing.
Yeah.
What's tangent? Sine over cosine. Now, I didn't put secant on the sheet because I do expect you to have some engagement in this. If cosecant is 1 over sine, then what's secant? 1 over cosine. Those are the reciprocal functions, you guys. So you better go back and do a little review, because that's the sheet you're getting. Now, what do we do after we get everything changed into sines and cosines? Anything on the top cancels with anything on the bottom, and that is it. So, top is sine squared, bottom is cosine squared. And what's sine over cosine? Tangent, so this is tangent squared. All right, now we're skipping down to 2A. Did I already do this problem?
No.
Nope. All right, here we go. Cosine 120. Now, what's the first thing I need to do when I have a problem like this? I need to draw it. And when I draw it, I remember my standard position labels. So 120 will be over here like this. This is 120. What do I do after I draw that? Drop a perpendicular straight down to the x-axis. Remember, I can't teach all this today, or tomorrow, or the next. I can't. You are going to have to review. If you don't know what I'm talking about, get out your chapter 4 notes and go. We drop a perpendicular and we figure out what this angle is. That is not 30. That's 60. Kids, think about it. If this is 120 and this is 180, doesn't that have to be 60? There's no hard math there. That's just logic. Now, look at your reference sheet. Right there is a 30, 60, 90 triangle. So the labels on a 30, 60, 90 triangle are those. The only thing you have to remember is sometimes we have negatives. In this problem, we're going to have a negative right here because of where that angle is. This is the origin. Left is negative. Now, cosine. Cosine is somewhere. Oh, here. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse would be negative 1/2. All right? So the amount of memorization you have to do is minimal. But you have to know how to set these problems up so that you can use your formulas. All right, next page. Let's look at problem 4A. Problem 4A says solve this logarithmic equation. Keep in mind, if there's no star by it, it's going to be on the no calculator page. So this is a no calculator problem. Anybody remember how to do this? It's 15 seconds. One step. Boom, got it. Yep, it's loop-de-loop. That's right, Olivia. It's loop-de-loop. So 4 cubed equals x. So 4 cubed is 4 times 4 times 4, which you can figure that out, you know, on your paper if you need to. You don't know that 4 cubed is 64. D. Here's D, problem D. 4D. Now, notice there's no star. This is not a calculator problem. You can do this without a calculator because 4 is 2 squared and 8 is 2 cubed. That's the key. They're both powers of 2. Now, the exam might not have 4 and 8. It might have 9 and 27. Those are both powers of 3. But if your problem looks like this, you need to make both of these the same. Now, those exponents didn't go away. They're still there. And this is a multiply, so it's going to be a distribute. So 2 to the 4x minus 6 equals 2 to the 9x plus 3. Now, what do you think we can do now? Common sense, logic. If 2 to this is 2 to this, then aren't these the same? So 4x minus 6 equals 9x plus 3. Then just solve it like a regular equation. So it looks like, if I did my math right, it looks like x is negative 9/5. Now that, this is problem E now, and E does have a star by it, because I'm gonna need a calculator for this one, because can I change 8 and 11 into the same thing like I did 4 and 8? No. So if you can't change them, then you're gonna have to use logarithms. Remember that handy little trick? And what happens when you take the logarithm? This guy comes out front. So x plus 1 log 8 equals log 11. What do you think? Our job is to get x by itself. So what do you think maybe we ought to do? Well, yeah, I'm going to put something in my calculator, but I got to know what to put in. How about if I divide log 8? So log 11 divided by log 8. So x plus 1 equals this, which is 1.153, But I want x, so I'll subtract 1. So my answer is 0.1531. I don't know how you'll round it off, how many places you'll round it off. Okay, so we took the logarithm of both sides, pulled the exponent off, and divided. All right, next is 6. How many radians is 500 degrees? Remember how to do this? How many radians is 500 degrees? Pi is 180, so something is 500. Remember that now that I wrote it down?
Yeah.
That's how you do it. That's how you do it. So pi is always 180. I want to know then how much is 500. So I'll cross multiply. And 5. And then remember, we did so many of these. Remember, you can almost always cancel out zeros. Not every time, but almost always. So then you got 50 over 18. And both of those are divisible by 2. So your answer is 25 pi over 9. Here's one we all get right. No one's going to miss this question, number 7. You've been doing it since you were 12 years old. What do we do? How do we solve something like this?
Get y by itself.
So one option is substitution, right? You can substitute. You know, I'm not going to because I don't like to do that. I like to eliminate. So I'm going to eliminate, but you can always substitute. That either one is fine. Whatever works for you is what you're going to do. He said if he's going to substitute, he says I'm going to have y by itself, and that's exactly what you want to do. I am going to multiply the bottom row by 5 so that my y's will be eliminated. Right? See how that works? Everybody remember that, right? That's elimination. You can do substitution. So 115 divided by 23, those are kind of big numbers, but you can do it. So x is 5, but you're not done. There'll be an answer blank sitting there, but don't put x equals 5 in it. What else do we have to do?
Find y.
We gotta find y. So I'm gonna go back to this equation right here. That's x. So 4 times 5 plus y equals 21. So it looks like y is 1. So my answer is 5, 1. Okay, so because that's on the no calculator part, I'm not gonna give you some wacky fraction crap going on, okay? You might have a half or something in there, but you're not gonna have 11 17ths to have to deal with. All right, now number 9, we need our calculators. We're gonna do both 9A and B. Says find the area of the triangles. All right, any area help on our reference sheet? I see 2 of them right there. Area equals, right? Those should look vaguely familiar to you. If they don't, you need to study them. We're going to use the one with the radical here. This is called Hero's formula. What does all that stand for in that formula, the one with the radical?
Side times side minus.
No, the S's aren't sides. Not in the one with the radical. The S's don't stand for side. What do the S's stand for? Half the perimeter. Oh my gosh, we have some review work to do. These problems are so easy. What's the perimeter of this triangle?
36.
36. The semi-perimeter is half of that, 18. So we put an 18 here, and then we do 18 minus each side. One more time. The time we spend reviewing in class is not going to make most of you pass. You are going to have to take these problems home and put some time and energy into it. They're easy. Oh my gosh, this is so simple. Multiply them all together, take the square root, and it looks like our answer is 54.99, if I did that all right. Now, I cannot do that with this other problem. Why? I don't have all the sides. So obviously, I'm not going to be able to do this part right here, which is crucial. So I'm going to use the other area formula, which says what?
1/2 AB sine C.
1/2 side times sine of the angle between them. That's what the formula says, 1/2 side sine. 1/2 side sine. And I just type it in. And that is 88.2 basically. Okay, no whining about how hard this exam is. We haven't done a hard problem yet. There's a lot of different kinds of problems. But if you study, you will pass this exam. All right, number 12 is another calculator problem. It looks very much like the one we just did. But it doesn't say find area, it says find C. You are not going to use an area formula. It doesn't say find area. What do we do to find a side? Well, Pythagorean theorem would be great if that were a
That's right, yep.
90-degree angle. It is not. So we're not going to be doing the Pythagorean theorem in this problem.
Isn't it sine C?
So we can at least think about using the law of sines. But remember, to use the law of sines, you have to have a pair. Remember that? Do I have a pair? So law of sines is not my thing. So if it's not law of sines, it's law of cosines, which is on there somewhere. It's the second thing from the top. That's the law of cosines. Law of cosines, familiarize yourself with it. It says c² equals 23 squared plus 16 squared minus 2 times 23 times 16 times cosine 47. Somebody else period says, Miss Ford, how do you know what's A, B, and C? It doesn't matter, because you're not memorizing the letters. You're memorizing the pattern. How does this formula work? C squared goes with this angle right here. Those go together. And then these are the other two sides. Just crank them in. The tricky part about this is remembering that at the very end, after you get it all typed in, you have to square root it. We sometimes forget that. I got 16.82. Now, in the matrix section here, we learned all this stuff, but I want you to focus on problem A, which says A plus 2B. So I want you to focus on that one, and on C, which says we are going to multiply these two things together. All right, so what do?
Distribute.
Distribute that 2 first. So we're gonna have 1, 2, 3, negative 5 plus 0, 10, 8, 2. And we just add them. So 1 plus 0, 2 plus 10, 3 plus 8, negative 5 plus 2. Now you're not gonna have a calculator for that, so you have to be careful. It's easy to make careless mistakes, just try to work carefully. Exam is really short. You know how yesterday's test was short? I told you it would be, and it was. This exam is short. You're not going to be rushed. I mean, you're gonna have to work, but you'll have time to work carefully. All right, now we're gonna multiply. So, 2 by 2, 2 by 2. 2 rows, 2 columns. These match. This is the size of my answer. So my answer is going to be another matrix that has 2 rows and 2 columns. So how do we find that number right there? We find 4 numbers. How do we find that number right there? Row 1, column 1. So we take row 1, which is 1, 2, and we match it up with column 1, which is 0, 4. We multiply each pair and add them together, so this number is an 8. Then we do the same thing here, only now it's row 1 and column 2. Multiply each pair and add them up. Then we're into the bottom row, so now we're going to use 3, negative 5, but we're going to pair it up with 0, 4, and 5, 1. We multiply each pair and add. I got negative 20 there, check my arithmetic, and 10. Here. Now, there's other things there. I really want you to focus your energies on the problems I'm doing today. All right? We are focusing on passing, because that's what's important to some of you, just to get through this. Those of you that are really trying to get that A, then you're probably going to want to do a little more on the sheet. All right. 14, I think I told you this already. I need to change that problem for you so it just looks like this. Did I tell you that? Your problem is just going to look like that. It's not going to have all that addition and subtraction and stuff. And you are only responsible for amplitude and period. So you will be responsible for either amplitude or period or both. What's the amplitude in this equation? 4. Perfect. If you graphed this thing, it's a negative sign curve. You're not graphing. Don't worry about that. You're not doing any graphing. But if you did, it would go down 4 and up 4. That's its amplitude. Period is the last number right here. Now, what is that last number supposed to be? 360. But, because 90, 180, 270, 360, you're not graphing though, so all you're interested in is the last one, which is supposed to be 360, but it's been divided by 2. That number divides. So your period is actually 180 degrees. Not hard at all. Something to remember. You gotta remember it, but it's not hard. Anybody listen to Mrs. Lewis's prayer this morning?
It didn't work.
Huh?
No, it was supposed to be, Mr. Wait.
They sent out another prayer.
Yeah, there was someone on CHS Live
Oh.
and they like didn't put it in or something.
Oh, well, anyway, so no one listened to Mrs. Okay, well, we did that because when we tried to load CHS Live, it wouldn't load, so I loaded the prayer first. Didn't realize there was another prayer. Oh, well, we did Mrs. Lewis's prayer, and it was all about hope. Hope. What I'm trying to do is give you guys hope. You guys that are in F-Bill right now, I'm trying to give you hope. You can pass this exam. Okay? Now, those of you that have, you know, you're sitting there with your 92 and you want an A, you can do that too. But I really want to communicate with my F'ers right now, and I mean kids with F's, that you can pass. Okay? But you've got to put some time and effort into it. Okay, 32 students in math class. I'm going to draw a Venn diagram because this just feels like a Venn diagram. Does it feel like a Venn diagram to you? Yep, because we've got kids that do what? There's 32 of them. Oh wait.
20 of them love log.
17 of them love both logarithms and polynomials. So 17 of them love both. 20 love logs. 22 love polynomials. How many love neither? So what I'm really looking for is this number right here, right? Okay, 32 kids in the class. All right. Total, this ball is 20, but 17 of them are already counted, so this must be a 3. 22 in this ball, but 17 of them are already counted, so this must be a 5. Now, how many are in the balls then? We got 3 and 17 and 5, so that's a total of 25. But there are 32 kids in the box, so 7 of them must be out here that don't like either. So there will be a question on the exam where you're going to draw a Venn diagram. Now, what question you answer, who knows? It might be, how many like only logarithms? 3. I mean, there's lots of different questions we could ask. All right. 18, find the 4th term of this expansion. Pascal's triangle, which is not on your sheet. Not on your sheet. So make sure you can write it out. I would practice it. And I'm not going to make you go to the 15th row or something. Make sure you can get out the first 5 or 6 rows. I stopped at row 4 because, does that say an 8?
Yeah.
Oh gosh, I said I wasn't going to go that far, but I did this time. Okay, here we go. Does anybody remember the other way to find these numbers? a lot of times this is just the easiest for kids, but it is kind of tedious. I didn't realize that was an 8. It's alright, we can do it. Anybody remember the other way to do it though, if you would prefer not to do this? They're the combination numbers, do you remember that?
Oh, yeah.
So, like, this guy right here is 8C8, 8C7, 8C6, 8C5, all the way down to 8C0. So you can always generate them that way too if you want. But there's the 8th row. Now, luckily, I don't want all of that. That would take a very long time. I want only the 4th one. So 1, 2, 3, 4. I want that 56 right there. And if I were writing out the whole thing, I would write out all these numbers, and then next to every number, I would put an X and a 4Y, remember that? And then I would be just about done, but I need my exponents. So if I were writing out the whole thing, this exponent would be 8 on the X. This would be X to the 8, 7, 6, 5. And if that one's a 5, this one will be a 3 because they have to add up to 8. And then I gotta look at this and multiply it all together. So I have a 56 and X to the 5th. Watch it. This is a 64 Y cubed. And then I'm going to multiply 56 times 64. 3584. X to the 5th Y cubed. And that is the answer to the question. Number 19. How many ways can a teacher give away a marker, a book, a crayon, and a calculator in a class of 24? So we're giving away a marker, a book, a crayon, and a calculator. So what? 24P4. I'm giving away 4 prizes. Marker, book, crayon, and calculator. So that would be a P problem, 24P4. I have 24 kids, I'm picking 4. That's a P or a C. Why is this one a P? Because the prizes are all different. So 20 order matters, 24P4, whatever that equals, you have a calculator, you can figure that out. Now, number 20. How many ways can I choose 3 boys and 3 girls from a group of 7 or 6 and 7? So I have 6 boys, and I'm going to pick 3. That marker's this one. And I have 7 girls. Where am I? 7 girls, and I'm picking 3. Yeah, take them one piece at a time. Does order matter? No. So there's 6 boys, and I'm going to choose 3 of them, right? And there's 7 girls, and I'm going to choose 3 of them. These are like the card problems where you pick 2 spades and 3 diamonds or something like that. Same exact concept. Type it in on your calculator, and that is done. Speaking of cards, number 21. A 5-card hand is dealt from a standard deck. What's the probability? Okay, this is going to be a fraction. Probability. This was not a fraction. This was not probability. As soon as you say probability, your answer is going to be a fraction. 5-card hand is dealt. What's the probability you will get at least 3 aces? Okay, what does that mean? At least 3 aces. Well, it means I could get 3 aces, or I could get 4 aces, right? So this is going to be 2 problems. But do each problem and then I'll add it together. So, 5-card hand. Denominator is going to be 52C5. Period. 5-card hand. Now, if I want exactly 3 aces, 4C3 and
times 48C2.
48C2. Because if it's a 5-card hand and 3 of them are aces, what are the other 2? Not aces. And there's 48 cards that aren't aces. Or, have I ever said this before? Yes. Or, what else can happen? I could get 4 aces. So that'll be 4C4 and 48C1. And that's going to be your answer. We don't have time to type all that in, but you'll type all that in, and that will be the answer to the question. 24. Eli caught 2 baseballs, 5 on the second day, 8 on the third day, 11 on the fourth day, and so on. How many will he have caught altogether if he continues this pattern for 100 days? So don't we want to go all the way out to whatever the 100th term is out here, and then add all those up? How many will he have caught altogether? All right, what kind of sequence is it?
Sum.
Well, I want a sum for sure, but I need to know what kind of sequence it is. Arithmetic. Because we are adding 3, right? So your arithmetic sum formula, which is on your paper there, on your reference sheet, is n over 2, first plus last. How many days am I adding up? N is how many days I'm adding. How many am I adding? 100. So 100 over 2. A sub 1 stands for the first day. Uh-oh, what does this stand for? The 100th day. Do I know what the 100th term is out there? So what do I do? Figure it out with my other formula, which says the first term plus the common difference times n minus 1. N is 100 in this problem. So every n is going to be 100. So that number is 2 plus 3 times 99, which is 299. That's how many balls he catches on the 100th day. So then I can plug that last term in, and it looks like my answer is 15,050. Now, not every problem is going to be a 2-stepper like that, but the moral of the story is, once you've figured out which formula you need, if you're missing something, then go to the other formula, and it will help you fill in what you're missing. All right, 27. 27A. What's the limit? 3/5. 3/5. Kate's horizontal asymptote limit. Same thing with an expression like this. It's 3/5. What about B? It's a little bit different. 0. Why is it 0, Eli? It's less than 1. 4/5, which is the number you look at, the one there in the parentheses, is less than 1. And when that's less than 1, the limit is 0. Okay? Now, 29 is one, well, we already did 29. 28 and 32 are the 2 we have left to do. So let's do 28 real quick. Now, when you did these before, I gave you some big thing like this, and I'm gonna FOIL it out, or I mean, factor it out. And you had to answer a whole bunch of questions. On the exam, you'll answer one or two. So for example, this one says, part A says, what are the vertical asymptotes? Vertical asymptotes come from the denominator. So there are two of them, 3 and -3. Holes, that's another possible question. What are the holes? Well, this one doesn't have any, because how do you get holes? You have to be able to cancel, remember? Another one is, what's the horizontal asymptote? Again, your exam is gonna have one or two of these questions. You're going to have a problem like this. What's the horizontal asymptote? Y equals 1. Isn't it x squared over x squared? That is also the limit, by the way. X-intercept. Those come from the numerator. This is stuff you're going to need to review. What x's give me a 0? Well, -1 and 1. Those are x-intercepts. And then your y-intercept, let x be 0, and it looks like we get 1/9. So, review those rules. You've got tons of examples, because we did it back in chapter 2, and then we did it again in chapter 7. So, you got tons of examples of those. Make sure you can find all this information, because you're gonna have to find one or two of them on your exam. 29, we already did. 32, find the vertices of this thing. All right, so where's the center of this thing? 1, -1. You need that. That's your starting point. And then you're going to count sideways 3. And those are actually your vertices. Now, this is where, how do you know that? Because you're also counting up and down 5. See that minus sign? This is a hyperbola, right? So I can count up and down 5, and I can build my box. But I can put in my asymptotes. But which way is this thing opening? Left and right. So these are the vertices. So the vertices are -2, -1, and 4, -1. Now, on your exam, feel free to draw the whole thing out if that's how it makes sense to you to figure it out. But the question's going to be find the vertices, or find the center, or find the slope of the asymptotes. You're only going to be finding one thing about this equation, not everything. Okay? All right, and we already did, well, quickly, we got time. Let's go ahead and get 29 done. What do we do with this guy? Leave the x go, because there's nothing to group with it, which simply means when I go to do my center, the x part is going to be 0. Now, I do need to group my y's.
+2.
No. Half of 4 is
Yeah,
2,
+4,
squared is 4.
Yep.
So the parentheses will be y minus 2. So my center is 0, 2, maybe that's what you meant.
Yep.
And what's my radius? When I add these, I get 14, so the radius is root 14. Okay, we'll do this again every period we have until the exam. Every period you have to come to class until the exam. But we have just gone through the meat and potatoes of the exam. So everybody